This is video number 1 for sections 6.1, 6.2, and 6.3, adding and subtracting polynomials. As we enter chapter 6, we are coming to our third major type of function this semester. We started with linear functions, and then we did exponential functions, and now we are going to talk about quadratic functions. Before we can talk about quadratic functions, though, we first have to spend some time reviewing how to do algebra with what are called polynomials. I've written a kind of a loose definition of the word polynomial here. This is not super precise, but I think it gets the idea across. A polynomial is the sum and/or difference of terms with whole number exponents. And I think if you take a look at the two examples here, you can see what I mean. I have a bunch of terms either being added or subtracted, and if I glance across at the exponents, they're all whole numbers. No fractional exponents, no negative exponents. You might also remember that we like to give names to our polynomials. For example, this first one would be called a cubic trinomial. The first word, the word cubic, refers to the fact that the highest exponent in this particular polynomial is a 3. That's often called the degree of the polynomial. So this is a cubic polynomial. The second word, the word trinomial, refers to the fact that there are 3 terms in this particular polynomial. So 2x cubed, negative x squared, and positive 1. Cubic trinomial. The second one is what we call a quadratic binomial. The word quadratic is the word we use when the highest exponent in our polynomial is a 2, as it is here. So that's the word quadratic. And then binomial simply means there are 2 terms this time, the 4y squared and the negative 5y. Quadratic binomial. Well, polynomials can be added, they can be subtracted, multiplied, divided, and we need to review how to do those things so that we'll be prepared to deal with quadratic functions in this next unit. Let's cover in this brief video just the idea of adding and subtracting. I've given an addition problem here with 2 polynomials. If you were to name them, they would each be called quadratic trinomials. They each have a highest exponent of 2, and they each have 3 terms. Well, you probably remember adding polynomials is very, very easy. It really just comes down to combining like terms. The parentheses in the problem are there just to show that yes, I had 2 trinomials, but mathematically they're not doing anything. The problem wouldn't change if I simply omit the parentheses. Let's do that quickly. Once I do that, I see I really just have a collection here of like terms. For example, I have the 3x squared and the negative 6x squared. Like terms, remember, are simply terms with the same variable part, same letter, same exponent. Let's see, I have a couple of terms with plain x's, and then I have a couple of terms with no x's. So I have 3 pairs of like terms, and I combine them by simply adding the coefficients and leaving the variable part the same. 3 and negative 6 makes negative 3. Keep that variable part the same, x squared. Plus x and negative 4x, that's like having a 1 plus a negative 4 makes negative 3. So I write minus 3x. And let's see, negative 1 plus 8 is positive 7. When you're done adding polynomials, you have a new polynomial. This one also happens to be a quadratic trinomial. And I don't have any other further way I can simplify this. I have 3 distinct terms. None of them are like terms. I have only a single plus or a single minus between each term. This is as good as I can get. Well, let's look then at the second example. This one is now a subtraction problem. you'll notice that there are both x's and y's in this example, and it doesn't really change anything. One thing that is true is it becomes a little bit more difficult to name these things. Since I have x's and y's, we would forego using that first word, and we'd probably just say this is a binomial minus a trinomial. This is very, very similar to what we just did above, with one additional twist. This time, the parentheses are doing something, at least that second set of parentheses. Having this minus there is kind of like having a minus 1 sitting in front, which means in order to deal with that, I'm going to have to distribute that minus 1 into all three parts. The first set of parentheses is not doing anything from a mathematical standpoint, so I can eliminate those, but then when I distribute, essentially all that happens is all the signs get changed. So now I have negative 2x squared, and I have negative 3xy, and I have positive y cubed. We distributed that negative 1 through all the three parts. Make sure and do that first, and then once you do that, you're just combining your like terms. Let's see, remember the variable parts have to be identical. This one has x cubed. None of the rest have that, so it's not like anybody else. This one has xy. Here's another one with xy. I think that's it. This one has x squared, no other matches. This one has y cubed, no other matches. So there's not a whole lot I can do here. I'll leave the x cubed. I can combine the two like terms. That would be like a negative 1 plus a negative 3 makes negative 4, so I write minus 4xy. And the other two, just keep writing them. There's nothing I can do. Here would be the final answer to that subtraction problem. Kind of a mess, but I can't really simplify it. One question that often comes up is, what order should I use when listing my terms? And I would say when there's only one variable, it's pretty standard. What people tend to do is start with the highest exponent and work their way down. So this was x to the 2, this was x to the 1, this was essentially x to the nothing because there's no x. So I think that's a good idea for you to get used to writing your terms in that order. That'll help in the next lesson. When there's more than one variable, it becomes a little less clear what you should do, and honestly it probably doesn't matter as much. So what I've written here is fine. I suppose technically what people tend to do is they pick one of the letters and they go in descending order of exponent with just that letter. So for example, if I picked x, I'd put the x to the third term first, and then I have this one with x to the second, and then I have this one that only has one x, and then I have the one that has no x's. So this is another perfectly acceptable form, and at least it has the advantage that the x exponents are going from highest to lowest. As long as the sign of the term stays with the term, you really can rearrange these in whatever order suits your purposes. So that minus 2x squared, as long as it still said minus 2x squared, I can move it around. We won't make a big deal about the order, and my math lab will not care what order you put these things in. One last comment, once you have four terms, like this answer does, we don't really have any special names anymore. We would just call this a four-term polynomial.